Okay, so in this video, I'm going to continue with what we were talking about with lines and planes and vectors here. And there are two different operations you'll need to know for vectors. And one of those is the dot product. Okay, and the way that the dot product works is you take each of the coordinates of the vectors and you multiply the corresponding coordinates. So let's do an example. I've got a good friend 2 comma 3 there, and we'll do -3 comma 2. And what we will do is write those both as vectors. So when you write it as a vector, we're using x on top of y, x comma y basically, and -3 on top of 2. And the dot product, if I wanted to do -3, 2, dot, 2, 3, the way you compute the dot product is by multiplying the two x coordinates and multiplying the two y coordinates and adding the answers together. So what we get is -6 plus +6, and we get the answer of 0. So for this particular example, the dot product of those two vectors would equal 0. And just remember that when I'm talking about it as a vector, we're talking about this line here and this direction and this magnitude in that direction right there. And those two vectors have a dot product of 0. Let's look at an example that does not give 0. Let's put on a different one here. Let's try -2 and -3. If I did the dot product of, let's make this a blue vector. If I did the dot product of -2, -3, there we go. Let's do that. So -2, -3, dot +2, +3. I'll get -2 times 2 plus -3 times 3, which makes -4 minus 9, which makes -13. Okay, so there's a few examples of just what is the dot product. You just take each component and you multiply them and add them up. Okay. One thing I hope you noticed is that these are not just random vectors. In fact, we found that these two vectors are perpendicular. And one of the most important things about the dot product is that when you have perpendicular vectors, your dot product is going to equal 0. So if, let's write that in general, if vector v and vector w are perpendicular, then what can we say? Then v dot w will equal 0. V dot w is equal to 0. I want you to think about why that's true. One way to think about it in terms of y equals mx plus b is that you have the opposite reciprocal slopes. And so you have taken your numbers and flipped them over and made one of them negative. And so you're doing rise times run, and adding them up together. And one of them will be negative and one will be positive. So you'll get an answer of 0. But the nice thing is that this dot product also extends up to 3 dimensions. So I'm going to switch from looking at Desmos, which is our 2-dimensional grapher, and I'm going to go on to a 3-dimensional one. So let's look at a couple of vectors here on our 3-dimensional grapher. Let's say that we have the vector of, let's do 1, 3, 5. It's a good looking vector right there. You can see it's going out. And then let's say I wanted to make a perpendicular vector to this. I would make it, I can do anything I want for the x coordinate. I can do anything I want for the y coordinate. And then all I need to do is think about what the dot product would be and what z coordinate I can pop in there to make it equal 0. So we can already kind of start to create the dot product here. Oops, let me get my pen back out. If we do 1, 3, 5, dotted with 3, 1, and the z coordinate. And if my goal is to get 0, then I can do 1 times 3 plus 3 times 1 plus 5 times z is equal to 0. So this is 3 plus 3 plus 5z equals 0. In other words, 5z is negative 6. Divide by 5, and z is negative 6/5. So what's kind of nice is if I go back to this second vector right here and just watch this part happen. So 1, 3, 5 versus vector 3, comma 1, and I got negative 6/5. We should get a vector that is perpendicular. Let's see if I can make that look nicer. I think if you look at it right there, let's zoom in a bit, you can see that there's a 90-degree angle between those vectors. And what gets a little complicated here is that there are obviously more vectors that are perpendicular to that. There are more vectors that have a dot product of 0 with that initial vector. So I'll return to that in the next video. But for right now, I just want you to remember the dot product means you're multiplying each of the coordinates and then adding those products together. And if the dot product is 0, then you have two perpendicular vectors.